Mute, mute.
I can hear your voice. Can you hear me?
Yes, sir. Yes, sir.
Yeah. So, good evening, everybody. This is Professor A.S.N.Chakravarthy, Director IT Infrastructure at JNTUK, Kakinada, Andhra Pradesh, a sister concern to JNTU Anantapur. So, in order to avoid the technical glitches, just I'm stopping my video. If there are any problem with my audio, Suresh or Chandusha, they can call me and tell me the problem.
Okay, sir.
See, in this particular session, we just give the brief introduction for AI and machine learning and deep learning. What are the different applications, real-time applications, what we have. And then also we see some of the research problems, what we can have related to AI and ML and also deep learning. Since my area of research is cybersecurity and digital forensics, so I take some examples where we can use this AI, deep learning or machine learning for the real-time cybersecurity related problems. So AI, which is a branch of science and also which assists all your machines to find solutions for all your complex problems. It's like a more human-like fashion where the next generation technology is nothing but artificial intelligence. Our future is lies in artificial intelligence. So wherever you go, like medical, finance, and the other areas, we find this artificial intelligence. So again, these the Sundar Pichai or Obama, Elon Musk or Jeff Boyce, they're all saying that AI is worth thinking about, where we can have many choices for problem solving. So machine learning and artificial intelligence. So where machine learning is a type of artificial intelligence that allows machines to learn and also which may improve from data without being explicitly programmed. So the problem here is how this machine learning will be used. So all the machine learning uses algorithms to analyze large amounts of data, identify patterns and make predictions. The more data a machine learning system is exposed to, the better it performs. So there are many examples related to machine learning, like streaming services, self-driving cars, fraud detection, and also image compression. Somebody is asking for image-related um, algorithms. There are so many algorithms which may be used, and somebody is asking about latest optimization algorithms. Let us see what may be the different latest optimization algorithms also we have, where you can use that for your image compression or image-related data analysis. So we have now, so like starting from industry 1.0 to industry 4.0. So initially we had that mechanization, steam and water power, and it goes to mass production and electricity. Now we have electronic and IT systems automation. Slowly we moved into AI related, that we call it as industry 4.0. And the importance of this industry collaboration in AI and machine learning is like it may be collaborated between academics and research, and also industry professionals plays a crucial role in developing AI and machine learning technologies, enabling the exchange of knowledge, resources, and expertise to drive innovation and also to solve complex real world problems. When we have seen this streaming services where it will suggest what are the new shows based on a view history. When it comes to the driving cars, self-driving cars, it shows how to do navigating safely. And when it comes to the fraud detection, it classifies the fraudulent and genuine transactions. And when it comes to the image compression, it tells about how to reduce the size of the data files. Not only that, there are many machine learning algorithms, and the importance of AI and ML in industry is mainly in order to enhance the efficiency and innovations. They have revolutionized various industries by enhancing efficiency, improving decision-making process, and also driving innovation through advanced data analysis and automation. So wherever you go, this AI and ML are following in the industry where mainly they are using for doing data analysis, and most of the tasks they want to do the automation. And some of the applications of AML, first one is automated customer support, where online shopping experience has greatly enhanced by chatbots. So nowadays, every application is having chatbot. Whatever you want to ask, it will give you the solution. So mainly, they increase the user retention by sending reminders and notification periodically. They offer instant answers compared to human assistants by reducing the response time. Earlier, before we have this automated customer support, whenever we want to have a particular answer for any query, if they are already ready with that, so we used to get it. Otherwise, we need to wait for the next day. Whereas these chatbots, they are providing unselling opportunity through personalized approach, and also periodically they are sending different reminders for all the peoples. Then the personalized shopping experience, people love to have this kind of personalized shopping experience. So the earlier we used to mention everything in order to buy something. As of now, for example, the other day I was shopping on Amazon. Okay, so I want to choose for a t-shirt or a shirt. Just I want to choose the size, whether it is XL or L or whatever it may be. So earlier, I used to the same Amazon experience, same Amazon shopping. Earlier, I used to choose whatever it may be manually, but the other day it was giving like it was giving suggestion. So based upon your previous purchases, based upon how you buy the things, we suggest you to buy something XL or L or whatever it may be. So I like that personalized shopping experience. So it's all because of the implementation of AI makes this online stores the smallest piece of data about every followed link, and you love this personalized experience. And Shivkumar told about different gadgets related to healthcare. So AI-enabled workflow assistance aiding doctors to free up their schedules, reducing time and cost by streamlining processes, and opening up new avenues for the industry. So AI-powered technology helping pathologists in analyzing tissue samples and thus in turn making more accurate diagnosis. So there they use different AI and ML related algorithms in order to have more accurate or precision results. And also finance. Most of the automated advisors powered by AI are capable of predicting the best portfolio to stock based on preferences by scanning the data. So the other day again I was scanning on a Facebook. Somebody he was giving he was guessing what kind of portfolios are best for stocks. So, from in turn, I asked him how he is doing all these things. He said he masterized in some of the AI tools where he is getting almost precision values for predicting something about the stock market. Maybe they were not right or wrong, but he said he is using artificial intelligence related tools in order to have that kind of stock predictions. And then also actionable reports based on financial data is also being generated by scanning millions of key data points. That is why it is saving the time for the analysts to give more data about any particular thing. Right. So the smart cars and drones, where most of the people use the smart cars, and autonomous vehicles running on the roads, and autonomous drones are delivering the shipments. A significant amount of transportation and service related issues can be resolved faster and most effectively. So AI-enabled mapping, those days were gone where people are using Google Maps. Now there are different types of AI-enabled mapping which scans the road information and also utilizes the algorithms inbuilt to identify the optimal route take. It may be a train, car, or whatever it may be. So based upon your vehicle, also it is giving the optimal route. Then the social media. Again, so Facebook uses advanced machine learning nowadays to do everything from serving content to you to recognizing your face in photos to target users with advertising. And also Instagram, which is owned by Facebook, nowadays it is also using the AI to identify the visuals. LinkedIn also using AI to offer job recommendations based upon your profile, and also it suggests people you might like to connect with and serving you to specific posts in your feed. Right, smart home devices, IoT devices, which are connected devices for all your smart home, and providing the data, and AI is learning from the data to perform certain tasks without human intervention. So most of the tasks nowadays they are automated, and most of the people they are using IoT related devices for their smart homes, where different AI related algorithms are embedded. And even the AI powered technologies can help musicians to create new themes. Most of the music directors they are using to create, and also they are creating arts also. The most important thing is security and surveillance, where it is making possible for the humans to constantly monitor and multiple channels with feeds coming in from a huge number of cameras at the same time. And even because of this AI and machine learning algorithms, so if you take a particular image from any of the CC cameras, so they may draw a route of a particular person, how many cameras he visited, and wherever the camera is installed, and if the particular person is traveled through so many cameras, the entire route, by the end of his route, the entire route of the particular face may be visible, or it may be drawn by these AI related algorithms. Right. So machine learning, as I said, which is the subset of artificial intelligence, and also deep learning is further a subset of machine learning. So machine learning is a specific technique used with the broader field of AI to enable machines to learn from data and improve their performance without explicit programming. While AI refers to the broader concept of creating intelligent machines that can mimic human cognitive abilities, including learning, reasoning, and decision making, which can utilize like ML to achieve its goals. AI is the overarching goal, and machine learning is one method to reach that particular goal by learning from the data. So, people may ask, sir, what is the difference between a machine learning and artificial intelligence? The scope is like AI is broad concept that encompasses various techniques from stimulating human intelligence, while machine learning is a specific approach within the artificial intelligence that focus on learning from data using algorithms. When it comes to the functionality, AI aims to create systems that can perform complex tasks like reasoning and decision making, while machine learning focus on identifying patterns in data to make predictions or classifications. When it comes to the implementation, the key difference is like AI systems might use a various methods, including machine learning, logic, and expert systems, while the machine learning primarily relies on statistical models and algorithms to learn from data. So when it comes to the example, the self-driving car that navigates roads, making decisions based on the sensors and environmental data comes under artificial intelligence. Whereas the algorithm within the self-driving car, which learns to identify the pedestrians from the images captured by the car, is comes under machine learning. Machine learning. Okay, so that is why the AI, machine learning, and deep learning all are of confused, but the technologies are separated, but they are related. So AI is a broad umbrella that encompasses a number of technologies, including this machine learning, deep learning, and all these things. Okay, so in this, as I said, the machine learning is a subset of artificial intelligence. So where you can see the deep learning, supervised learning, unsupervised learning, semi-supervised learning. We talk about the neural networks. We talk about natural language processing. We talk about evolutionary computation. We talk about expert systems. And also we talk about vision, where computer vision, machine vision, robot vision comes. And also we talk about robotics. Then we talk about speech interpretation, and all these things comes under machine learning. So machine learning mainly categorized into three: supervised learning, unsupervised, and reinforcement learning, where the regression classification comes under supervised learning and clustering comes under unsupervised learning, and whatever the decision making comes under reinforcement learning. So the supervised learning uses the label training data to teach algorithms to recognize patterns and predict outcomes. A human teacher, what he do is he provides any algorithm with labeled examples that combine problems and solutions. The algorithm then learns the relationship between input and data. Whereas in the unsupervised learning, which uses unlabeled data to teach algorithms to identify patterns and structures in the data, the algorithm works independently to learn the data without any specific guidance. So when it comes to the supervised and unsupervised learning, there are a few basic differences in terms of accuracy, human intervention, applications. So when it comes to the accuracy, supervised learning models are usually more accurate than unsupervised learning models. When it comes to the human intervention, supervised learning requires human intervention to label the data. Unsupervised learning also requires some human intervention to validate the output variables. When it comes to the applications, supervised learning is used to solve a variety of problems. Unsupervised learning is better suited for more complex processing tasks, such as organizing large data sets into clusters. So you can ask me, sir, what may be the examples for this? A supervised learning model can predict how long you can commute based on the time of the day, weather conditions, and so on. Whereas unsupervised learning model can identify online shoppers often purchase group of product at the same time. So that is why whenever you are purchasing something, the related products will be displayed on your Amazon or Meesho or whatever it may be. Yeah, is statistics used in machine learning? Yes, statistic is a core component of machine learning. So we see about the supervised learning. As I said, it involves training a machine learning model with labeled data and performing classification and regression tasks. And the machine learning algorithms such as CA, girl classification can be applied in various real world scenarios to leverage the proper power of the supervised learning. And unsupervised learning, as I said, which will be encompasses essential techniques such as clustering and association problems, which enables the identification of patterns and rules within the data. And through the real world examples of clustering and recommender systems, we witness the power of unsupervised learning in uncovering hidden groupings and extracting valuable insights. So you can see clearly the difference between supervised and unsupervised learning, which relies on the labeled input and output training. Here, this so unsupervised learning processes the unlabeled or the raw data. So there are various Uses of supervised in machine learning, like in bioinformatics, speech recognition, object recognition, in traffic prediction and email span, and also in image classification. So in turn, each one can be used in different applications. Okay, so this is the most common used algorithm, k-means clustering, where we have the unlabeled data which will be converted into labeled clusters, where we have the centroid for each and every cluster. This is the most commonly used algorithm, the k-means unsupervised machine learning clustering algorithm. So here where the cluster refers to collection of data points aggregated together, which may be having the similarity. And this k-means clustering is one of the simplest and popular unsupervised machine learning algorithm. So when you see most of the people initially they start with this k-means algorithm where they give different data, and because through this k-means they want to group the data which are having similar attributes. In association rule is a kind of unsupervised learning, so which tests for the reliance of one data element on another data element, and also it may be designing appropriately so that it can be more cost effective. So if, for example, in association, what they do is, as I said, in the online shopping, if customer is purchasing a particular item, through this unsupervised learning or this association rules, what they do is they also guess or they also recommend. So this particular item or this particular dress or whatever it may be, you may purchase or it may be suitable for you. That kind of uh, association they can give you. Okay, so mainly this kind of unsupervised learning they are using in online shoppings or the other online related activities. Even nowadays, the Facebook also giving based on your history or based upon your data. So you can have a friendship with this particular person, or so you have some kind of mutual friendship with this particular person. So like this also it is giving recommendations in the Facebook. So uses of unsupervised machine learning, like as I said, anomaly detection, segmentation, social network analysis, identification of cancer cells in health, and also in search engine optimization also we can use. So these are the basic differences we have with supervised and unsupervised. Where here we have input is labeled and input is unlabeled. No feedback mechanism. We have the feedback mechanism here in supervised learning. Data is classified based on the training data set, and it is assigning properties of given data to classify it. Here we have divided into regression and classification. It is divided into clustering and association. It is used for prediction and it is used for analysis. So we have decision tree, logistic regressions, support vector machine comes under supervised, whereas k-means clustering, hierarchical clustering, a priori algorithms comes under unsupervised. Is my voice is clear? Hello? Is my voice is clear? Audible?
It's clear.
Thank you. And semi-supervised learning, an approach to machine learning that combines a small amount of labeled data with a large amount of unlabeled data during the training. So this semi-supervised learning falls between unsupervised learning and supervised learning, which gives the pseudo-labeled data set, which may be used for machine learning model trained on labeled, and you can get a huge data set out of this. So where you see small amount of labeled data set is mixed with a large amount of unlabeled data set, and you are getting pseudo labeled data set. Right. So then we have something called as association problem, where we are discovering rules through unsupervised learning. We have the clustering and association problems, which are the fundamental concepts in artificial intelligence and machine learning. By applying these unsupervised learning techniques such as clustering and also recommender systems, we can identify patterns and grouping within the data, which enabling us to discover valuable rules and insights. So we'll move on to the next thing, that is classification and regression problems. They are the two fundamental tasks in supervised learning. Classification involves in predicting discrete labels or categories, while regression involves predicting continuous numerical values. So these two are widely used in various industries, like predicting customer churn in telecommunication or estimating the house prices in real estate. And machine algorithms such as decision trees, logistic regressions, support vector machines, they can be applied to solve this classification and regression problems, and they can make accurate predictions based upon whatever training data you give. The linear regression involves in the analysis of dependent and independent variables to establish a relationship between them, and it relies on the assumption of linearity, where the best fitting line is determined to represent the data. Additionally, it explores the importance of error variance and caution against the solely relying on R squared values for the interpretation. So people ask about linearity and variables. So this is the key concept in the linear regression, where the relationship between dependent and independent variables is expressed as a straight line. And dependent variable is the outcome what we predict, and while independent variable are the factors that we use to make predictions. And it's very important to know that the best fitting line is determined by minimizing the sum of squared errors, and caution is advised when interpreting R squared values, and we can reflect the true predictive power of the models. So there are some assumptions and interpretations related to linear regressions. And people ask about, sir, what is the relationship between regression and classification? So regression and classification algorithms are supervised learning algorithms, and both are used for predicting machine learning, and they work with labeled data set. But the only difference is how they used the data for different machine learning algorithms. How they used are for different machine learning algorithms. Okay, so where classification is a process of finding a function which helps in dividing data into two classes based on different parameters. In classification, a computer program is trained on the training data set, and based on the training, it categorizes the data into different classes. For example, in order to understand the classification problem in email spam detection, the model is trained on the basis of millions of emails on different parameters. And whenever it receives a new email, it identifies whether email is spam or not. If the email is spam, then it moves to the spam folder. Okay, and there are different types of machine learning classification algorithms we have, like logistic regression, k-nearest neighbors, support vector machines, kernel SVMs, naive Bayes, decision tree classification, random forest classification, and so on. When it comes to the regression, is a process of finding correlationship between dependent and independent variables. It helps predicting continuous variables, and it also do some kind of prediction of market trends and house prices. And the task of regression algorithm, whatever it may be, is to find mapping function to map the input variable X to the output variable Y. You can see some example here. We are given the regression between student profile and what kind of percentage they may get. Something like the house prices. Okay. And simple regression algorithms we have is linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree regressions, random forest regressions, and so on. These are some mass stats components which are used in industry on daily basis. Okay, mean, median, standard deviations to confident intervals, hypothesis testing, and probability, and there are so many mathematical statistical components used in industry. So they discover how these components are leveraged in AI and machine learning through data visualization, regression analysis, and neural networks with the real life examples to showcase their practical examples, sorry, practical applications. So when it comes to the mathematical components like mean, mode, median, variance, standard deviation, confidence, interval, hypothesis testing, probability are very essential in various industries where they predict something, they guess something. So in A and ML, all these components find application in data visualization, again regression analysis and neural networks, and also they enable practical examples in the real world solutions. As I said, different classification algorithms, decision tree, logistic regressions, random forest, naive Bayes. Not only this, we have support vector machines. We have a kernel SVM also. So the decision tree is very specific type of probability tree which enables you to make any decision about some kind of process. It's something like yes or no tree. Whereas the random forest is the classification algorithm consists of many decision trees. You can see n number of decision trees we have. Based upon that, we have the classification of the data. And naive Bayes is also one of kind of a classification algorithm, mainly for binary, like two classes and multiple classes classification problems. Okay, so based upon applying Bayes theorem, we have a probability or prior algorithms. Then comes to the logistic regression, which may be mainly used to calculate or predict the probability of any binary event like yes or no events. So there are examples of machine learning algorithms, as I said, supervised learning in depth, classification and regression, car and girl classification examples. When it comes to the clustering, we have fundamentals of unsupervised learning, real world examples of clustering. There are different recommender systems we have with the unsupervised learning techniques, which can be used as association rules. And they can also develop different recommender systems for the personalized recommendations. So these are the different applications of machine learning. Comes from the traffic prediction, stock market trading, automatic language translation, self-driving cars, virtual personal assistants, and so on. So when it comes to the fraud detection, so industry application and case studies of AI and ML, there are different challenges in the finance related sectors where the financial fraud will be detected. The academics and educators are interested in incorporating real world case studies and industry applications into their curriculum. So, in order to demonstrate the use of machine learning and detecting financial fraud, so we try to detect and prevent fraudulent activities in financial transactions using machine learning, where we analyze large volumes of transactional data and also identify patterns and accurately detect what may be the fraudulent activities we have, which enables the financial institutions to mitigate the risk and protect against financial losses. They may be used in banking sector or stock market and so on. So these are the main industry applications of AML or ML in finance. One is risk management, the other one is algorithmic trading, credit scoring, automated trading systems, and fraud detection. So wherever you go, they use the machine learning models in order to take the decisions and also give some kind of feedback to the management as well as the users of the system. Reinforcement learning, as I said, which is also one of the important machine learning training. which is based on the rewarding something like desired behaviors or punishing desired ones. So you can see this is one of the example which is related to reinforcement, where the goal of the robot is to get the reward, that is the diamond, and avoid hurdles that are filed. So the what in this learning, what happens is the robot learns by trying all the possible paths and then choosing the path which gives him the reward with least hurdles. That is a game which is developed to show the example of reinforcement. So where we have some kind of environment and we need to change the state and do some actions in order to get the reward. So that is what we call it as rewarding desired behaviors or punishing the desired ones. As I said, this reinforcement machine learning can be used in personalized chatbots and also in self-driving cars and video recommendations in OTT related streaming websites. So this is the a training data set which is implemented to build up any model, while a test set is validate the model is built. In the process of training and testing, there could be different problems that you want to avoid. Okay, the original data to the training data, the data which you give as an input for any algorithm may be vary. See, we have a regression, classification, and deep learning for the same data, and you can see the graphs, how they are. As I said, all are associated. So the deep learning is a type of machine learning based on the artificial neural networks in which multiple layers of processing are used to extract progressively higher level features from the data. So any mention of deep learning will soon be followed by the term neural networks. The concept that deep learning is modeled on the human brain's processing capabilities. Uh, and there are some facts like deep learning is a subset of machine learning. Deep learning functions similarly to machine learning using algorithms and vast amount of data, but the capabilities go far beyond the machine learning, so its results seem more intelligent and sophisticated. Instead of one or two algorithms working at once, as in machine learning, deep learning relies on more sophisticated model that layers algorithms. This is known as artificial neural network or ANN. So it is the artificial neural network that inspired theoretically by our own brains, and neural networks continually analyze data and update predictions, just as our brains are constantly taking information and drawing conclusions. Deep learning examples include identifying faces from pictures or videos and recognizing a spoken word. But one major difference between deep learning, unlike machine learning, will correct itself in case of a bad prediction, rendering the engineers less necessary. For example, if a light bulb had deep learning capabilities, it could respond not just to its dark, but to similar phrases like "I cannot see where is the light switch" and so on. So when choosing between the two, like machine learning and deep learning, a quick way to separate machine learning and deep learning is like machine learning algorithm uses to make decisions based on what it has learned from the data. But as I said, deep learning uses algorithms in layers to create an artificial neural network that makes intelligent decisions on its own. While machine learning might feel less sophisticated than deep learning, it shouldn't immediately get passed over in favor of the mightier deep learning. In fact, machine learning makes sense for smaller data sets and less complicated tasks or automation. So what may be the weakness of the machine learning and deep learning? So there may be positives and advantages, but the takeaways are like deep learning and machine learning are different. They are both tools within the world of artificial intelligence, but neither is the silver bullet to achieving AI. Investing in other AI approach is also a key to its potential, right? So people who are interested in machine learning, they can use the Python, R programming, or JavaScript, and also Julia for writing programs and implementing their algorithms. Okay, so exploratory data analysis, they are doing unwanted data and unorganized data. They can be distributed and they are making the model inefficient. Okay, so this is how we extract the data, we transform the data, we use different data mining algorithms in order to have the interpretation and making, changing, transforming the data into the knowledge in different phases. So, like, what may be the future of machine learning? Internet of Things, machine automated machines. It may improve the cybersecurity, the ethics in artificial intelligence, automation of NLP or natural speech understanding process, general adversarial network, and also so on. Right. People may ask that is there any step-by-step process or guide to choose the best machine learning algorithm for your projects? So you may choose any project. Okay, it may be related to healthcare, it may be related to medical, or it may be related to finance, it may be related to cybersecurity, or it may be related to cloud, or whatever it may be. So there is some step-by-step guide to choose the best machine algorithms. The first step is to identify the problem. So, where we know the machine learning is a powerful tool that can be used to solve a wide range of problems. However, with so many different models to choose from, it can be challenging to know which one is right for your project. So, in this process, as I said, we'll take you to a step-by-step process, which may be help you to choose the best learning method for your needs. Remember, for your needs. So the first step is to identify the problem you want to solve. Identify the problem which you want to solve. Is it a regression, classification, or a clustering problem? Then this will help you to narrow down your options and determine which type of model to choose. Then what type of problem are you trying to solve? Whether it is a classification problem or clustering problem. If it is a classification problem, then you need to see to the logistic regression, decision tree classifier, random forest classifier, support vector machines, naive based classifier, or neural networks. So if it is clustering related problems, then you can use k-means clustering, hierarchical clustering, or DB scan clustering. So that is first step, that is identify the problem which you want, what type of problem it is, whether it is a classification problem or clustering problem. Based on, you can choose the algorithms. Then in the step 2, consider the size of your data set, which can also influence your choice of model. If you have a small data sets, you may want to choose a model that is less complex, such as linear regression. For large data sets, more complex models like random forest or deep learning may be appropriate. Then, as I said, you choose what is the size of your data sets, which is a large data set, like which is having thousands to millions of rows. Then you can go for the gradient boosting algorithms or deep learning models. If it is a small, where we have less than 1,000 rows, you can go for logistic regression or decision tree or naive Bayes. In the step 3, you need to determine whether you have a labeled or unlabeled data, which is very important. Labeled data is a predetermined outcome, while unlabeled data does not. If you have a labeled data, you can use supervised learning such as logistic regression or decision tree. If it is unlabeled data, on the other hand, which requires unsupervised learning algorithms like k-means or principal component analysis, which is called as PCA. Okay, as I said, labeled data go for supervised learning models like logistic regression, decision tree, SVM or neural networks. Unlabeled data go for unsupervised learning models such as k-means, clustering, hierarchical clustering or DB-scan. In the step 4, you should consider the nature of your features. What is the nature of the features in your data set? The nature of your feature also determine which model to choose. If your features are categorical, you may want to use the decision or naive base. For numerical features, linear regression or support vector machines may be more appropriate. And what nature, as I said, it is categorical, decision tree, random forest, naive base. Numerical, go for linear regression, logistic, SVM, neural network, k-means. If it is mixed features we have, then go for decision tree and random forest or SVM or neural network. In step 5, you should decide whether interpretability or accuracy is more important. Some machine learning models are more interpretable than others. If you need to interpret your model's results, you may want to choose models like decision trees or logistic regressions. If accuracy is more critical, then go for more complex models like random forest or deep learning may be better suited. The step 6 is mainly for account for imbalanced classes. If you are dealing with imbalanced classes, you may want to use models like a random forest, SVM, or neural networks to address the issues. And in step 7, which address missing values in your data. If you have missing values in your data set, you may want to consider imputation techniques or models that can handle missing values, such as k nearest neighbors or decision trees. In step 8, it may be consider the complexity of your data. If you suspect there may be more non-linear relationships between your variables, you may want to use more complex models like neural networks or SVMs. It's all based upon whether your data is low complex, more complex, or high complex. Based on that, you can choose your algorithms. Then comes to the balance, speed, accuracy. Consider the trade-off between speed and accuracy for your use case. More complex models can be slower. Remember, more complex models may be slower, but they also provide higher accuracy. So based upon your, if the speed is more important, go for decision trees, logistic regression, and so on. If the accuracy is more important, then go for neural networks, random forest, SVM, and so on. Then the addressing high dimensional data and noise. If you are dealing with high dimensional data and noisy data, you may want to use dimensionality reduction techniques like principal component analysis or models that can handle noise such as KNN or decision trees. Again, so the level of noise is very important whenever you are choosing the data here. See, all these steps are suitable for all kind of problems. The only thing is just take the problem and take all these questions and answer it. Definitely you will get which kind of algorithm is suitable for my problem or my research work, whatever it may be. Choose a model that can predict in real time. So if you want to need a model that can predict in real time, you may want to choose models like decision trees or SVMs. And then if your model addresses outliers, then you may want to use a robust models like SVM or random forest or decision trees. And if you consider models for sequential data such as time series or natural language, You may want to use models like recurrent neural networks or long short-term memory, that is LSTM networks, and so on. So are you looking for any model that determine your desired level of interpretability? So you need to understand how your model is making its predictions. You may want to choose a more interpretable model such as decision tree or logistic regression. On the other hand, if accuracy is your top priority and you don't need to understand how the model is making its predictions, you may to choose a less interpretable model such as neural networks. So here in the last step, you should see you have the trade-off between high interpretability and low interpretability. So based on that, you may choose different algorithms. So then move on to the general examples. If you see here, this is a AI generated fake video and audio. So nowadays we are getting different phone calls where people are calling and you are getting different videos where a deep fake comes and also a voice, AI generated voice is also coming. So this is also a deep fake using the artificial intelligence. See, so that was the real and this is the fake, which they have printed in the newspapers, and they said that these wrestlers are not serious about their fight and whatever it may be. Okay. So as I said, slowly we moved into the one of the topic which is related to cyber security. Machine learning and artificial intelligence can help enable cyber tools, which may uncover different patterns of attackers in the using different machine learning approaches. So the ability to predict the exact actions an attacker might take as a part of an intrusion prevention system would allow us to proactive measures to prevent the attack from happening in the first place. Some of the benefits of machine learning offers cybersecurity for business and consumers is like they have the systems for scanning data breaches, malware, and more. They have the end protection through quick remediations and also fast analysis of large amounts of data. They can also do adjustments without need for the expert input. Okay, so the Microsoft they are using the machine learning for their own cybersecurity platform that is called as a Windows Defender Advanced Protection. Also, the Chronicle they are using their own cybersecurity for various problems, and Splunk they are also using a variety of applications including IT operations analytics and the Splunk, which is giving the enterprise security and user behavior analytics. They are using the machine learning where they can detect different threats quickly and they can be eliminated. And SQRL, the founders, they are using different machine learning algorithms for cyber threat hunting, and they turn data points into behavioral maps, which acts like a visual representation of any computer network. So shows where the threats could be coming in. Okay, and there are the other things like BlackBerry. They are using in California. They are using different algorithms for the threat detection. So people who may do the research in computer related things, if you want to see a research model for representation of cyber threat in machine learning environment, you can see this. In the realm of cybersecurity, ontologies are used to represent the real world inside a machine learning environment. We can observe that in this ontology, you can see malware sitting at the center, surrounded by various other entities that could relate that malware. For example, the entity malware category could be a banking trojan or a worm, and the attack vector entity might indicate either a spam or SQL injection. or a particular vulnerability to malware is exploiting. So using this type of ontology, a machine can begin to understand the real world, in this case, the threats faced by a network. Of course, in order for any machine to build up a comprehensive picture, it needs consume a data and it has to classify any data points it recognizes that refers to these particular entities. The next step is to convert all those entities into events, which in turn will have their own classifications. For example, the attacker, targeter, the method he used, and so on. So that same kind of research model you can use for different environments also. And there is something called as a rule-based approach to identify a cyber attack. If you see in the image shown, you can see an example how this might work in practice. The data point in case of a post on a Twitter is being analyzed using a simple rule-based approach. This is looking to identify the entities that would indicate a cyber attack. Okay, it's able to identify an operation, it's able to identify two organizations, and it may also be able to identify a target. For example, this type of system offers huge benefit to field of cybersecurity, where it can process a huge data points very quickly, irrespective of the source language, whatever it may be, XML or HTML, whatever it may be. And one more example related to machine learning is like a threat intelligent machine. So the toughest part of the threat intelligent machine process for human is the collection and processing the data. Okay, so this type of automated process here detailed about that takes all that heavy lifting away and which paves the a way for the approach where the human analyst can make decisions based upon insights produced by the machines. In order for this process to function seamlessly, machines must provide intelligence in a way that easy for human analysts to understand and act on. So this is a threat intelligent machine built on a machine learning algorithms. So as shown in this model, starting from the text extraction to the event prediction in all scenarios, the properties of machine learning is playing a very pivot role. As I said, there are major applications of machine learning in cybersecurity where it comes under incident response and forensic, in ransomware, DDoS attacks, in DNS poisoning, in fraud detection, and also which may used for human analysis in different cybersecurity skill gaps, and also in data breaches. So one of the application of artificial intelligence and machine learning is deploying honeypot to provide security, which gathers information about attackers and their exploitation methods. It's typically the target of highly sophisticated attacks, which provides a window into types of attacks that being launched. So whatever honeypot we install on a system, which collect new and emerging malwares, identify the source of the attacks, and also which determine the attack vectors, and mainly it builds a profile of the target industry or hacker if using specific industry domains. So whoever may be doing some kind of research here, they can deploy honeypots in public cloud infrastructures around the world in order to observe the type and frequency of attacks. And these solutions are cloud deployable, and also they must contain advanced security contents and analytics. And first of all, we can create a cloud environment which consists of number of nodes. Then we can apply all these honeypots using different algorithms. So the algorithm is like the sender may be sending packets and another node getting the IP of the sender. The honeypot, which is containing the central center, which may be having some snort rules. The honey gateway is implemented at the level of cloud nodes, and all these gateways are used for repeated detection of attacks in the packets. So this is how the honey net will be used in order to redirecting an outbound attack. And one of the important research where you can concentrate on like hacker profiles. So based upon the input of different things, you can predict whoever may be the cyber criminal is. In the hacker profiling or steps in the generated profiling, we use the machine learning methods for criminal where you can use the real rule based detection and also different machine learning algorithms, and you get some output out of this. So you give the input. Uh, so the, sorry. So this is the input table what we have where you give a C1, C2, and so on, and you use the machine learning something like this where in the investigation you provide all the variables and that data will be trained using some inference engine and also takes data from the police database. And then we have the output which will be displayed to you, which gives this kind of data where it may give the age, the social background, maybe the professional motivation or the financial motivation of the criminal. So this is very useful for the people who are working in cybersecurity related things, and the same kind of prediction you can use for the other problems also. So deep learning is area of artificial intelligence where the real magic is happening right now. So as I said, this is the deep learning where you can have the pre-execution prevention, like prevention is better than cure. And also the deep learning in cybersecurity we can use for malware detection also. So there are different capabilities of enhanced detection using this deep learning, which is suitable for cyber security related threats. Okay. If you see here, the deep learning may be used for the malware analysis, intrusion detection, for traffic analysis, spam detection, log analysis. So most of the things can come under that deep learning and machine learning algorithms. Okay. So machine intelligence is the last invention that humanity will never need to make. Okay, so we are using AI, using self-driving cars. We are using different things, and we are using the statistics techniques like future scaling and outlier detection for preparing data for machine learning algorithms. Okay, so we use different classification algorithms and clustering algorithms and regression algorithms. So remember, one point is like programmers are working on different AI tools that don't rely on machine or deep learning or rethinking our approach to definition of intelligence. Thus, they are seeking answers to questions that these models can't comprehend because there aren't tasks. For instance, can an application go beyond recognizing words to understand the concepts? Can data be used efficiently for different types of analysis? So remember, the takeaways from this, the deep learning and machine learning are different. They are both tools within the world or wide world artificial intelligence, but we need to choose wisely which algorithm may be suitable for you. So fields like finance, parts of healthcare benefit from machine learning and data learning, but industries where tasks or data are fuzzy are not reaping these benefits. When it comes to the decision making, like predicting an election or writing a essay, deep learning may be pummeling directly into a technical wall. That's because teaching common sense is a lot harder than teaching task. So common sense, perhaps a shorthand for thinking, is a broader, less tactile process that may produce vague outcomes. So I wish all the best. I thank the organizers for giving me this opportunity. Thank you, one and all. Just I want to share something. I'm pasting something in the chart. So that is a neural network playground. Can you see that? A neural network playground. Already link is there. So this you can use, or if you want to play with this, so you can increase the number of hidden layers. You can change the learning rates. So you can use different activation functions, and you can test it if you are teaching this kind of subjects. So if you want to create some interest in your students or people who are learning this kind of algorithms, you can use this. So there are so many this kind of websites you can explore whenever you are teaching this kind of subjects. Okay. Somebody asked about the new optimization algorithms we have. Like we have the flood algorithms for engineering optimization. We have the red, build, blue, magnify optimization for different planning algorithms. We have ADAX optimization algorithm for vessel designing. Not only this, like a particle swarm optimization, we have BAT algorithms, we have bee colony optimization, we have the artificial bee colony optimization, we have the cuckoo search optimization, we have salt swarm optimization, which can be used for different optimization techniques. So that's it from my end. Thank you very much. Thank you.
We are grateful to you, sir, for contributing significantly to this FDP through your valuable insights and engaging presentation. We would like to hear more from you in the future, sir. Thank you so much.